Chapter 4. Aircraft Drawings. Introduction. The exchange of ideas is essential to everyone, regardless of their vocation or position. This exchange is usually carried on by oral or written word, but under some conditions, the use of these alone is impractical. The aviation industry discovered that it could not depend entirely upon written or spoken words for the exchange of ideas, because misunderstanding and misinterpretation arose frequently. A written description of an object can be changed in meaning just by misplacing a comma, and the meaning of an oral description can be completely changed by using a wrong word. To avoid these possible errors, drawings are used to describe objects. For this reason, drawing is the draftsman's language. Drawing, in the aviation industry, is a method of conveying ideas concerning the construction or assembly of objects. This is done with the help of lines, notes, abbreviations, and symbols. It is important that the aviation mechanic who is to make or assemble the object understands the meaning of the different lines, notes, abbreviations, and symbols that are used in a drawing. See the lines and their meanings section of this chapter. Computer graphics. From the early days of aviation, development of aircraft engines, and other components relied heavily on aircraft drawings. For most of the 20th century, drawings were created on a drawing board with pen or pencil and paper. With the introduction and advancement of computers in the later decades of the 20th century, the way drawings are created changed dramatically. Computers were used not only to create drawings, but they were being used to show items in virtual reality, from any possible viewing angle. Further development of computer software programs allowed for assembling of separately created parts to check for proper fit and possible interferences. Additionally, with nearly instantaneous information sharing capability through computer networking and the internet, it became much easier for designers to share their work with other designers and manufacturers virtually anytime, anywhere in the world. Using new computer-controlled manufacturing techniques, it became possible to design a part and have it precisely manufactured without ever having shown it on paper. New terms and acronyms became commonplace. The more common of these terms are: 1. Computer graphics. Drawing with the use of a computer. 2. Computer-aided design, CAD, where a computer is used in the design of a part or product. 3. Computer-aided design drafting, CADD, where a computer is used in the design and drafting process. 4. Computer-aided manufacturing, CAM, where a computer is used in the manufacturing of a part or product. 5. Computer-aided engineering, CAE, where a computer is used in the engineering of a part or product. As computer hardware and software continue to evolve, a greater amount of CAE is completed in less time, at lower cost. In addition to product design, some of the other uses of CAE are product analysis, assembly, simulations, and maintenance information. Figure 4.1. CATIA, ProEngineer, SolidWorks, and Unigraphics are some of the more popular CAD software packages used for aircraft design and manufacturing. Most airframe manufacturers use CATIA software to design their aircraft. The complete aircraft is designed and assembled in the software package before it is manufactured. Drawings of all parts of the aircraft are available and can be accessed using the computer software. Drawings are no longer limited to 1, 2, or 3 views. Drawings from every angle can easily be accessed by using the computer model of the part or product. Technicians can access drawings in aircraft manuals on laptops or even mobile devices when performing maintenance on the shop floor. Purpose and function of aircraft drawings. Drawings and prints are the link between the engineers who design an aircraft and the workers who build, maintain, and repair it. A print may be a copy of a working drawing for an aircraft part or group of parts, or for a design of a system or group of systems. They are made by placing a tracing of the drawing over a sheet of chemically treated paper and exposing it to a strong light for a short period of time. When the exposed paper is developed, it turns blue where the light has penetrated the transparent tracing. The inked lines of the tracing, having blocked out the light, show as white lines on a blue background. With other types of sensitized paper, prints may have a white background with colored lines or a colored background with white lines. Drawings created using computers may be viewed on the computer monitor or printed out in hard copy by use of an inkjet or laser printer. End of page 4-1. Larger drawings may be printed by use of a plotter or large format printer. Large printers can print drawings up to 42 inches high with widths up to 600 inches by use of continuous roll paper. Figure 4.2. Care and use of drawings. Drawings should be handled carefully as they are both expensive and valuable. Open drawings slowly and carefully to prevent tearing of the paper. When the drawing is open, smooth out the fold lines instead of bending them backward. To protect drawings from damage, never spread them on the floor or lay them on a surface covered with tools or other objects that may make holes in the paper. Hands should be free of oil, grease, or other unclean matter that can soil or smudge the print. Never make notes or marks on a print, as they may confuse others and lead to incorrect work. Only authorized individuals are permitted to make notes or changes on prints, and they must sign and date any changes they make. When finished with a drawing, fold and return it to its proper place. Prints are folded originally in an appropriate size for filing. Care should be taken so that the original folds are always used. Types of drawings. Drawings must give information such as size and shape of the object and all its parts, specifications for material to be used, how the material is to be finished, how the parts are to be assembled, and any other information essential to making and assembling the object. Drawings may be divided into 3 classes: detail, assembly, and installation. Detail drawing. A detail drawing is a description of a single part, describing by lines, notes, and symbols the specifications for size, shape, material, and methods of manufacture to be used in making the part. Detail drawings are usually rather simple. When single parts are small, several detail drawings may be shown on the same sheet or print. Figure 4.3. Assembly drawing. An assembly drawing is a description of an object made up of 2 or more parts. Figure 4.4. It describes the object's size and shape. Its primary purpose is to show the relationship of the various parts. An assembly drawing is usually more complex than a detail drawing and is often accompanied by detail drawings of various parts. Installation drawing. An installation drawing is one that includes all necessary information for a part or an assembly in the final installed position in the aircraft. It shows the dimensions necessary for the location of specific parts with relation to the other parts and reference dimensions that are helpful in later work in the shop. Figure 4.5. Sectional view drawings. A section or sectional view is obtained by cutting away part of an object to show the shape and construction at the cutting plane. The part or parts cut away are shown by using section, cross-hatching, lines. Types of sections are described in the following paragraphs. Full section. A full section view is used when the interior construction or hidden features of an object cannot be shown clearly by exterior views. For example, Figure 4.6 is a sectional view of a cable connector and shows the internal construction of the connector. Half section. In a half section, the cutting plane extends only halfway across the object, leaving the other half of the object as an exterior view. Half sections are used with symmetrical objects to show both the interior and exterior. Figure 4.7 is a half-sectional view of a capstan servo. Revolved section. A revolved section drawn directly on the exterior view shows the shape of the cross-section of a part, such as the spoke of a wheel. An example of a revolved section is shown in Figure 4.8. End of page 4-2. Removed section. A removed section illustrates parts of an object. It is drawn like revolved sections, except it is placed at one side and often drawn to a larger scale than the view indicated to bring out pertinent details. Figure 4.9 is an illustration of removed sections. Section AA shows the cross-sectional shape of the object at cutting plane line AA as section BB shows the cross-sectional shape at cutting plane line BB. These sectional views are drawn to the same scale as the principal view. Title blocks. Every print must have some means of identification. This is provided by a title block. Figure 4.4a The title block consists of a drawing number and certain other data concerning the drawing and the object it represents. This information is grouped in a prominent place on the print, usually in the lower right-hand corner. Sometimes the title block is in the form of a strip extending almost the entire distance across the bottom of the sheet. Although title blocks do not follow a standard form as far as layout is concerned, all of them present essentially the following information. 1. A drawing number to identify the print for filing purposes and to prevent confusing it with any other print. 2. The name of the part or assembly. 3. The drawing scale. 4. The date. 5. The name of the firm. 6. The name of the draftsman, the checker, and the person approving the drawing. Drawing or print numbers. All prints are identified by a number that appears in a number block in the lower right corner of the title block. It may also be shown in other places, such as near the top borderline, in the upper right corner, or on the reverse side of the print at both ends so that the number shows when the print is folded or rolled. The purpose of the number is quick identification of a print. If a print has more than one sheet and each sheet has the same number, this information is included in the number block, indicating the sheet number and the number of sheets in the series. Figure 4, 4B. Reference and dash numbers. Reference numbers that appear in the title block refer you to the numbers of other prints. When more than one detail is shown on a drawing, dash numbers are used. Both parts would have the same drawing number plus an individual number, such as 40,267 to 1 and 40,267 to 2. In addition to appearing in the title block, dash numbers may appear on the face of the drawing near the parts they identify. Dash numbers are also used to identify right-hand and left-hand parts. In aircraft, many parts on the left side are like the corresponding parts on the right side but in reverse. The left-hand part is always shown in the drawing. The right-hand part is called for in the title block. Above the title block a notation is found, such as 470204-1LH shown, 470204-2RH opposite. Both parts carry the same number, but the part called for is distinguished by a dash number. Some prints have odd numbers for left-hand parts and even numbers for right-hand parts. Universal Numbering System. The Universal Numbering System provides a means of identifying standard drawing sizes. In the Universal Numbering System, each drawing number consists of 6 or 7 digits. The first digit is always 1, 2, 4, or 5 and indicates the size of the drawing. The number 1 indicates a drawing of 8.5 times 11, number 2 indicates an 11-inch by 17-inch drawing, number 4 represents a drawing of 17 inches by 22 inches, and 5 indicates a width of between 17 and 36 inches but on a continuous roll. Letters are also used, and becoming more prevalent, with the most common letters being A through E. The letter A is 8.5 times 11, B is 11 inches by 17 inches, C is 17 inches by 22 inches, D is 22 inches by 34 inches and E is 34 inches by 44 inches. There are additional letters, such as D1 at 24 inches by 36 inches, E1 at 30 inches by 42 inches and additional sizes unique to even larger formats but generally reserved for intercompany operations. The remaining digits identify the drawing. Many firms have modified this basic system to conform to their needs. The letter or number depicting the standard drawing size may be prefixed to the number, separated from it by a dash. End of page 4 to 3. Figure 4, 3. Detail drawing. End of page 4 to 4. Figure 4, 4. Assembly drawing. End of page 4 to 5. Figure 4, 5. Installation drawing. End of page 4 to 6. Other numbering systems provide a separate box preceding the drawing number for the drawing size identifier. In another modification of this system, the part number of the depicted assembly is assigned as the drawing number. Drawing standards. Drawing standards cover such items as paper sizes, notes, numbering systems, geometric dimensions and tolerances, abbreviations, welding symbols, roughness symbols, and electrical symbols. These standards cover metric and inch measurements, as well as computer drafting standards. Different standards for drawings are used in industry, and some of the more common ones are published by the International Organization for Standardization (ISO) and the American National Standards Institute (ANSI). Bill of Material. A list of the materials and parts necessary for the fabrication or assembly of a component or system is often included on the drawing. The list is usually in ruled columns that provide the part number, name of the part, material the part is to be constructed of, the quantity required, and the source of the part or material. End of page 4 to 7. A typical bill of material is shown in Figure 4, 4C. On drawings that do not have a bill of material, the data may be indicated directly on the drawing. On assembly drawings, each item is identified by a number in a circle or square. An arrow connecting the number with the item assists in locating it in the bill of material. Other drawing data. Revision block. Revisions to a drawing are necessitated by changes in dimensions, design, or materials. The changes are usually listed in ruled columns either adjacent to the title block or at one corner of the drawing. All changes to approved drawings must be carefully noted on all existing prints of the drawing. When drawings contain such corrections, attention is directed to the changes by lettering or numbering them and listing those changes against the symbol in a revision block. Figure 4, 4D. The revision block contains the identification symbol, the date, the nature of the revision, the authority for the change, and the name of the draftsman who made the change. To distinguish the corrected drawing from its previous version, many firms are including, as part of the title block, a space for entering the appropriate symbol to designate that the drawing has been changed or revised. Notes. Notes are added to drawings for various reasons. Some of these notes refer to methods of attachment or construction. Others give alternatives, so that the drawing can be used for different styles of the same object. Still others list modifications that are available. Notes may be found alongside the item that they refer to. If the notes are lengthy, they may be placed elsewhere on the drawing and identified by letters or numbers. Notes are used only when the information cannot be conveyed in the conventional manner or when it is desirable to avoid crowding the drawing. Figure 4, 4E. Illustrates one method of depicting notes. When the note refers to a specific part, a light line with an arrowhead leads from the note to the part. If it applies to more than one part, the note is worded to eliminate ambiguity as to the parts it pertains to. If there are several notes, they are generally grouped together and numbered consecutively. Zone numbers. Zone numbers on drawings are like the numbers and letters printed on the borders of a map. They help locate a point. To find a point, mentally draw horizontal and vertical lines from the letters and numerals specified. The point where these lines intersect is the area sought. Figure 4, 4F. Shows the zone numbers on a drawing. Use the same method to locate parts, sections, and views on large drawings, particularly assembly drawings. Parts numbered in the title block can be located on the drawing by finding the numbers in squares along the lower border. Zone numbers read from right to left. Station numbers and location identification on aircraft. A numbering system is used on large assemblies for aircraft to locate stations, such as fuselage frames. Fuselage station 185 indicates a location that is 185 inches from the datum of the aircraft. The measurement is usually taken from the nose or zero station, but in some instances, it may be taken from the firewall or some other point chosen by the manufacturer. Just as forward and aft locations on aircraft are made by reference to the datum, locations left and right of the aircraft's longitudinal axis are made by reference to the buttock line and are called butt stations. End of page 4 to 8. Vertical locations on aircraft are made in reference to the waterline. The same station numbering system is used for wing and stabilizer frames. The measurement is taken from the centerline or zero station of the aircraft. Figure 4, 10. Shows use of the fuselage stations, FS. Waterline locations, WL. And left and right buttock line locations, RBL and LBL. Allowances and tolerances. When a given dimension on a print shows an allowable variation, the plus, figure indicates the maximum, and the minus figure the minimum allowable variation. The sum of the plus and minus allowance figures is called tolerance. Figure 4, 4G. For example, using 0.225 plus 0.0025 minus 0.0005, the plus and minus figures indicate the part is acceptable if it is not more than 0.0025 larger than the 0.225 given dimension, or not more than 0.0005 smaller than the 0.225 dimension. Tolerance in this example is 0.0030, 0.0025 max plus 0.0005 minutes. If the plus and minus allowances are the same, you will find them presented as 0.225 plus or minus 0.0025. The tolerance would then be 0.0050. Allowance can be indicated in either fractional or decimal form. When very accurate dimensions are necessary, decimal allowances are used. Fractional allowances are sufficient when precise tolerances are not required. Standard tolerances of minus 0.010 or minus 1/32 may be given in the title block of many drawings, to apply throughout the drawing. Finish marks. Finish marks are used to indicate the surface that must be machine finished. Such finished surfaces have a better appearance and allow a closer fit with adjoining parts. During the finishing process, the required limits and tolerances must be observed. Do not confuse machined finishes with those of paint, enamel, chromium plating, and similar coating. Scale. Some drawings are made the same size as the drawn part, reflecting a scale of 1:1. Other scales may be used. However, when drawings are made on a computer, drawing sizes may be easily increased, zoom in, or decreased, zoom out. Some electronic printers have the same capability. Furthermore, when a 1:1 copy of a print is made, the copy size may differ slightly from that of the original. For accurate information, refer to the dimensions shown on the drawing. Figure 4, 4H. Application. When shown near or in the title block, application may refer to a specific aircraft, assembly, subassembly, or unique application. For example, in Figure 4, 4A. The title block indicates the bracket assembly is for a roll servo installation for an S-Tech autopilot installation. If this drawing pertained to a B-95 aircraft equipped with an Aerotech air conditioning system and the bracket illustrated was unique to that installation, the title block would provide that application information. The title block may indicate bracket ASI, roll servo, with Aerotech air conditioner, model at 103-1. Installed. Methods of illustration. Applied geometry. Geometry is the branch of mathematics that deals with lines, angles, figures, and certain assumed properties in space. Applied geometry, as used in drawings, makes use of these properties to accurately and correctly represent objects graphically. In the past, draftsmen utilized a variety of instruments with various scales, shapes, and curves to make their drawings. Today, computer software graphics programs show drawings at nearly any scale, shape, and curve imaginable, outdating the need for additional instruments. Several methods are used to illustrate objects graphically. The most common are orthographic projections, pictorial drawings, diagrams, and flowcharts. Orthographic projection drawings. To show the exact size and shape of all the parts of complex objects, several views are necessary. This is the system used in orthographic projection. In orthographic projection, there are 6 possible views of an object, because all objects have 6 sides: front, top, bottom, rear, right side, and left side. Figure 4, 11a. Shows an object placed in a transparent box, hinged at the edges. The projections on the sides of the box are the views as seen looking straight at the object through each side. If the outlines of the object are drawn on each surface of the box, and the box is then opened, Figure 4, 11b, to lay flat, Figure 4, 11c, the result is a 6-view orthographic projection. It is seldom necessary to show all 6 views to portray an object clearly, therefore, only those views necessary to illustrate the required characteristics of the object are drawn. 1-, 2-, and 3-view drawings are the most common. Regardless of the number of views used, the arrangement is generally as shown in Figure 4, 11, with the front view as principal view. If the right side view is shown, it will be to the right of the front view. If the left side view is shown, it will be to the left of the front view. The top and bottom views, if included, will be shown in their respective positions relative to the front view. One-view drawings are commonly used for objects of uniform thickness, such as gaskets, shims, and plates. End of page 4 to 9. Figure 4.10. Station numbers and location identification on aircraft. End of page 4 to 10. Please like, share, shop, and subscribe to our channel. Chapter 4 Part 2 is coming soon.